Welcome back to the second half of the 2022 Blue Planet Berlin Water Dialogues. We've got an exciting program ahead, so we're going to get straight to our next keynote speakers. Joining me now are Andrea Cominola and Riccardo Taormina. Gentlemen, please take it away.
Thanks a lot, Jennifer, for this introduction. And it's really a pleasure to be here today and to share this keynote with Riccardo. So let me share the slides we've prepared. When preparing this keynote, we started wondering ourselves whether this topic of the disruption of AI in the urban water sector is rather a myth or actual reality. And as two academicians, we do a lot of research, we do teaching, and we work at the university. In order to answer this question, we wanted to really look into what the utility, the water industry sector says. And in this regard, there's actually an important document, the Digital Water Report prepared by the IWA, the International Water Association, and Xylem together, where basically they talk about this digital water, which is just a synonym, for digital transformation of the water sector, and several keywords to give a name to the same concept. And in this report, AI is not just a standalone technology. AI is, let's say, one of the enabling technologies, one of the driving forces of what is called more broadly digitalization, along with sensors and capability to monitor and forecast variables in our water systems and data processing in general, so AI also and machine learning, and even to some more visionary elements like augmented and virtual reality. So in this document, it's actually quite interesting because it really appears from what they found and what is claimed in the report that all these technologies, so the digital transformation as a whole, is actually providing a lot of opportunities for the water sector. For instance, extend water resources, capacity expansion and conservation, reduce non-revenue water, expand infrastructure life cycles, provide the basis for financial security, etc., etc. So there are plenty of opportunities that are actually opened up by the AI and in general digital transformation in the water industry. Let's say that moving from what can be possible, the opportunities, we've been talking a lot about opportunities in the first part of this event today, and moving from this opportunity to actually what is done, that requires some action. And in the same report, they actually provide a really nice picture of how water utilities adopt technologies. They provide this digital water adoption curve that is a 5-stage S-shaped curve. You see from the left-hand side, it means not started, no digital technology adopted at all. Moving then to the right-hand side with transformational, that means that the industry sector is fully transformed. So out of this report, the good news is that after interviewing about 40 water utilities worldwide and leading experts in the sector, they found that most of these utilities could be labeled or located in this curve in the area of opportunistic, which means that they already started the digital transformation journey. They did it actually already to a more advanced level than just some basic adoption. And that means that automation and control, for instance, have been already adopted in many operations within a water utility. So good news is that this digital transformation started, and AI as part of this transformation is also playing a role into this. Probably a bit less good news is that you see this shape of this curve as an S shape looks more like something that needs several steps to be completed. So it looks more like an incremental process, more something like gradually increasing. With a different survey that's called Smart Water Survey that we led at TU Berlin together with several co-authors worldwide, and supporters, again, with the IWA and several other international organizations like Water Europe and the Smart Water Networks Forum, we tried to go deeper into this. So we wanted to look behind this curve and understand which differences exist, which drivers can actually push a faster adoption of technology, and whether there are differences between subsectors and utilities. So we also interviewed several water utilities worldwide, 64 to be specific. You see with a let's say, larger concentration in Europe, but then also a global coverage with utilities of different sizes and ownership type, primarily public utilities, but also private ones. And we found two key interesting aspects out of the answers that they gave us. First of all, what are the drivers of digital transformation? So what can push this digital transformation and this digital technology adoption to be faster? Well, what we found, and it's in these 5 figures here, each refers to a different subsector of the cyber-physical infrastructure of water utility, is that governmental and hydroclimatic factors play a role. So governmental influence normally with regulations, the water sector is heavily regulated, or with incentives, for instance, to adopt technology. Hydroclimatic factors instead primarily with challenges. Think about water extremes, hydroclimatic extremes like droughts and floods. So they play a role. However, the factor that I haven't mentioned so far, but is indeed the one playing the largest role, is economic factors. You see from the curves represented here that 42 to 85% of the utilities indicated that the economic factor is actually the one primarily driving technology adoption. Probably nothing surprising, but it's actually interesting that this is confirmed throughout all sectors and to a larger extent than the other 2 types of factors. So building a business case, finding actually a proper usage also in an economic perspective, even by utilities like public ones that probably are not necessarily entirely driven by revenues, is still the important factor. So in order to push this adoption of technology, the economic factors play a role, and we should leverage them to support this entire transformation. Second, penetration of digital technologies. As measured by the UDS, Utility Digitalization Score, that we formulated from 0 to 3, the higher, the more a utility is digitalized. Also in this case, we see that on average, all the utilities that participate in our survey are quite digitalized, already to a level of 1.52 or 2.5 out of 3, which means they're quite advanced already. And that confirms the results of the IWA report. So this opportunistic label that was given to many utilities is confirmed also here. However, second important thing here to take home, this distribution look quite wide. There's a lot of dispersion. So that means that different utilities and different subsectors go to a different pace and at a different stage of digitalization. So let's go now back to the original question. We were wondering, digital water and AI in the water industry, is this really a disruption? So what I can say is that, there are several other industrial sector, economic sectors, where disruption actually happened already. Think about, for instance, the entertainment sector with all the recommended systems that now can tell us the music and suggest music that we like based on our preferences. Or think about language processing and generation. There's this Bloom that is able to generate any sort of text in 8 different languages and counting. Think about, for instance, machine learning and AI in genomics, where our ability to understand and process our genome is getting quicker and more easy and understandable. Or think about the autonomous driving sector, that there's a lot of hype around that. Even the art sector is being, to some extent, or is undergoing some sort of disruption with all the pros and cons and controversial aspects that we can also read in the newspaper articles. So there's a lot happening in several other sectors. Now, in the water sector, thinking about this S-shaped curve that we've seen from the IWA report, and thinking about what we found in our survey and the fact that these 2 global surveys only managed somehow to reach 40 to 60 utilities, knowing that in the world there are several thousands, millions, if not of utilities, then basically this is quite suggesting that the digitalization, the digital journey has started, but yet there are still several steps to go. And since I'm on this slide with this artwork, I like to exploit this to actually conclude this part about disruption, yes or no, with another piece of art that actually I generated with AI. So actually, I just wrote some text. It's a person and an artificial intelligence drinking water while sitting at the bar, and this looks like a Picasso painting. So the message is that digitalization has started, but the water sector and indeed AI, in order to complete this digital transformation, need to sit really down together and talk and have a mutual understanding. It's not just a one direction dialogue in this way. The water sector comes already with a lot of expertise that was pretty much highlighted by Oliver Gibson in the first part of this event. The AI comes with a lot of techniques. So the two worlds should really meet by having a mutual understanding of this. And in order to accomplish this, there's a lot of challenges that we need to overcome. So these barriers that are giving the name to this second slot in the event today. And this is where my colleague Riccardo Taormina will take over and present you which challenges are actually the major ones affecting this process and how we can deal with that. So Riccardo, I hand it over to you.
So it's very nice to be here with all of you. And indeed, I would like to discuss these three main challenges that I see concerning AI in the urban water sector. And I would like to start from data, which is probably the biggest challenge of all. Indeed, so some of these major AI breakthroughs that we see in the news every day, which have been also introduced by Andrea, we know that to achieve these amazing results, whether for like natural language processing or even art generation, we need to train these very sophisticated machine learning models and deep learning models using a huge amount of data. So we are really talking about terabytes of data. You can see some figures there. So we should ask ourselves whether, to reach like important breakthroughs in the field of AI for the urban water sector, we actually need this data set of this size, and whether we can obtain them, right? If you remember the very nice presentation we had this morning from Cella Nevo of Google, it was mentioning about these remarkable improvements that LSTM networks achieved in terms of rainfall runoff modeling. And he was talking about data sets such as camels or caravans, which enable these achievements. And maybe you'll be happy to know that this data set, you can download them, of course. We are talking about gigabytes of data, so not terabytes of data. So they are big, quite big, but they're not like, as big as the one used by Bloom, for instance. We're talking about 350 billion words. So this should be somehow encouraging. As a researcher in the field of AI for the urban water sector, I'm still, though, struggling with, getting this type of data from water utilities, which are in the end, of course, the owners of this data. And then, because maybe you don't need to have billions of data points, less will suffice to have some important, let's say, breakthroughs. But of course, we have to consider that, when it comes to water utilities, we are talking about critical infrastructure. So we have a lot of problems related, for instance, to regulation, especially with concerns regarding cybersecurity, security in general, and also privacy. So it's somewhat somehow counterintuitive, but it's easier to get data from a satellite than from a smart meters, at least for training your AI models. Also, this was you're not seeing my screen? Oh, that's strange. Do you see it now? Oh, strange. Okay, sorry, guys. You didn't miss much. Anyway, so I was talking about the challenges that we have in obtaining a large data set from utilities. And I was talking about regulation, security, and privacy. Also, it was mentioned by Oliver Gibson earlier today. There is the problem that sometimes it's actually tough to generate data, and it's very tough to, generate data of a certain quality. So it requires, budget, resources, skilled personnel, and so on and so forth. And also, we have this overhead that sometimes is not considered in terms of budget and resources when you want to make this data systematically available to, either like researchers within your institution, your organization, or outside of it. So these are indeed problems that we need to face. And that's why usually, let's say, AI researchers in the water sector try different strategies to overcome this limitation, right? So one of the main strategies is that of resorting to simulated data. Again, this was somehow touched upon in the first panel discussion, right? So synthetic data is actually quite interesting and important, can solve some problems, but in the end, it's not fully representative of real situations, right? So we can move closer to the real world by using test beds. For instance, here I bring as an example the KWR test water distribution network, which we have in the Netherlands. And it's a very, very interesting setup. We're talking about 400 meters of pipes that really represent well, what we can find in a real Dutch water distribution system. But again, this is a very large installation, so they're expensive to run. And also there is no guarantee that actually, let's say, the AI models that we train on this network can actually scale well and generalize to the real world. And that's why one of the more recent trend is that of building machine learning models that exploit inductive biases, that exploit the sort of prior information that we have, for instance, on the physics, the chemistry, and the biology that govern water processes. By developing, let's say, these PINs, this GNN, this scientific machine learning tool, we would be able to solve the same problem using less data. At the same time, though, we would require more expertise, which could be a limitation. I would like to end this part on data by showing you an amazing example of a data set, for AI, for training AI model for the urban water sector. You might be familiar with it. This is called Sewer ML. Is indeed, we're talking about, as you can see here, 1.3 million images of sewer sections, in normal condition and also defective. And then this amazing data set, which have been created by Aalborg University in collaboration with 3 different water utilities in Denmark, shows that actually we can almost generate a data set for training AI models, which are somewhat comparable to the very famous, for instance, ImageNet or COCO data set that have been used to advance AI in all the other fields that we discussed before. So indeed, things can be done. There is a lot that can be done. Of course, it requires collaboration. It requires a lot of work, but this is valuable work because already a data set like this has been utilized to push forward the boundaries, let's say the edge of performance when it comes to defect detection in sewer systems. Now I would like to move to something which is partially related, which is the second challenge that I introduced in the beginning, and is that of code availability and reproducibility. So we should know by now that you need big computers, you need big data, but also to advance AI, you need open source code. So all the deep learning frameworks, PyTorch, TensorFlow, and so on and so forth, they were available to everybody from day one. In the same way, we had actually the implementation of state-of-the-art algorithms and the trained models. Most of them are also available to everyone. Indeed, it's almost impossible to publish in, let's say, major venues of computer science and AI if you don't share your code, and also if you don't share sufficient details for other people to replicate your results. Unfortunately, the situation is extremely different when it comes to, let's say, AI application in the urban water sector. Code is indeed very rarely shared by both researchers and practitioners, which is a huge limitation in my opinion. And also result reproducibility is actually not something that is requested for publication, not even for very, let's say, machine learning related publication. Anyway, of course, we can do better than this, and I hope there is going to be a way forward to improve this because it's going to be extremely beneficial. And I would like again to talk about the Sewer ML work done in Denmark, because not only they made available this amazing data set, but they also made available code, models, and even a platform for you to train your model on the same, to actually test your model on the same data set, which is remarkable and indeed can be, should be taken as an example to continue in this direction. At the same time, we're seeing some important, let's say, developments also among publishers. For instance, the very important Journal of Water Resources Planning and Management now awards, it gives awards and also recognition to those papers that did, let's say, to try to improve a lot shareability of the code, of the models, and also result reproducibility. So this is certainly going to boost things in the future, I hope. I want to end with this last few slides, which are related to the AI skill set that we can have in the water sector, because we know the AI is required everywhere. And of course, we know also that there are some sectors which are much stronger financially than the water sector. I'm talking about salaries and opportunities for people working in this field. Of course, this makes it quite hard to recruit high-skilled personnel in the water sector when it comes to AI. However, we are witnessing this sort of saturation elsewhere. You can think of the recent layoffs at Meta, Twitter, and Amazon. And this may indeed ease the problem in the future because these people may move to other sectors, including our sector. But as we've been discussing already quite extensively today, usually the water sector, when it comes to AI, actually requires even hybrid profiles. Maybe the majority of them should be hybrid profiles. So we want tech-savvy people, but also they should be knowledgeable of the underlying physical processes. So that's why, for instance, me at TU Delft, but also Andrea at TU Berlin, we are including more and more data science and AI in our Master of Science curricula in water management, for instance. And I would like to conclude these slides. This is one I generated, of course, because indeed the future, even in the medium and the long term, is not that AI is going to, of course, completely replace humans. We're going to always have this sort of human in the loop setting where, human and sort of consult with the AI to solve technical tasks. So that's why, it's very important to have these hybrid profiles, knowledgeable of AI, data science, but also of water processes. And with this, I would like to end our presentation. And thank you for following us.